We are often asked to verify inverse functions. Verifying inverse functions means that we want to prove that the two functions actually are inverses. And there are two things we have to show. We have to show that f composed with the inverse is equal to x. And we need to show that the inverse function composed with the function equals x. Remember back to composite functions, order matters. So we want to show that both of these equal x. Look at the example below here. F of x is equal to 2 times x plus 3. The inverse function of f is equal to x minus 3 divided by 2. Remember what we said about inverse functions. They undo each other. One has multiplication and addition. The other has subtraction and division. These should be inverse functions. But in order to prove it, in order to verify, we have to do both of these. Now you've been practicing finding inverse functions. So why don't you find, first of all, number 1, f composed with the inverse function. So the first thing you did was substitute the inverse function into the function f. And then you were able to simplify. 2 times a half is 1. And we see that f composed with the inverse function does indeed equal x. Now I would like you to compose the inverse function with the function. Again, you should have found this was equal to x, but your work should look a little different. We put the function into the inverse function. We changed x, and then we found that half of 2x is equal to x. We've proven that these are inverse functions. So 2 more for you to try. First of all, find f composed with the inverse function. Write down all of your work so that if I ask you to show this to me when we verify your test, or if you're writing a paper test, you can do it. The substituting is definitely a little bit tricky here. All of this x has to become the inverse function. And then of course you have 1 minus 1. And I didn't write out this step here, but I hope you know that this is 1 divided by 1 over x, which is equal to 1 times x, or just x. Now find the inverse function composed with the function. So again, the substituting is a little bit weird here, right? This x has to become all of 1 over x minus 1. And I don't know if you all know this, not a trick, but it's a basic math concept, that 1 over x always equals x. So when I had 1 over x minus 1, it was equal to x minus 1. It's a useful thing to know. You don't have to write out all of the steps then. You can just go ahead and get straight to what you're doing. So again, we've shown that these are inverse functions, and your ability to do this algebra, manipulate the terms, the variables, the factors is important.